All right, here we go. So just want to mention over here, let's see if I can open here one document. I don't know which lecture would that be. Let me try to open 418 spring. I don't think you see it. Lectures, probably 2 lectures ago. A little bit more. 2, 3. Okay, so let me drag it over here. So you might remember these lectures over here, where we have this expression for the shear flow. Okay, so we say the term, this term over here, this is common, this term over here takes care of the skin of the panels, okay, the webs, and this one was taking care of the booms, okay, or idealized structure. So far, what we have been doing is just dealing with the shear, with this, and saying that the skins were not effective in resisting shear. So we were basically saying that the thickness was 0, or ignoring this term, and we were just working with this term. Yeah, I'll probably put that somewhere at the bottom, I'm guessing, or not. Okay. But basically, that's what we have been doing. We have been saying that the skin is not resisting any of the shear, but just the boom or the flanges. Okay, so today the example I'm going to do is the opposite. We're going to say everything is skin, and there is no booms or lunges or anything to resist the shear. Okay, it's something you should have done in Structures 1 for open sections. We're going to do it for cross section, and I just do one example, and I don't go back because they take a long time. So that's what we're doing today. So here we go. All right, so example. Okay, so in this case, we're gonna have so no booms or lunges, just panels. Imagine you just make a box by folding a sheet of metal. And we're gonna have this is 0.1, 2, 3, and 4. S12 equal to 20. I'm copying all this stuff from my MATLAB. S34 equal to S12. S23 equal to S41 equal to 10. Okay, then I'm going to have the thickness of 1,2 is 0.05. Thickness of 2,3 is 0.1. Thickness of 3,4 equal thickness of 4,1 equal as well to 0.05. And all these measurements are in inches, okay? Yes. Please zoom in a little bit, please. Yes. Just let me know when I move out of the page, okay? Okay. Okay, so in this example, in here, skin is effective in resisting shear. Okay, so what does that mean is that if we go back to this equation, and in this case, we're going to have all the b sub r's are going to be 0. Okay, in this problem, I forgot to put the force. I think it's only a Vy. And then we're going to have the is symmetric, so Rxy will be 0. Vx will be 0, so all this equation will simplify. And this will simplify to, okay, so we're going to have the expression so that we're going to have the expression Q of S, or Q, will be equal to minus dy over Ixx and now this should be here the term. I'm going to call this S instead of X and Y, because when we go around the surface, this could be X or Y, no? Okay. So we go around. Okay, so in this case, let's say all the B sub R's are 0, no? So there's no boom, no longerons, so the effect will be 0. Okay, so this is 0.05, this is 0.05. So basically, this is symmetric. So the cross section is symmetric with respect to the x-axis. If you want, you just call this x-axis, okay. Okay, so the first thing we're going to do before starting to do all the calculations, let's determine first, let's say determine cross-section properties. So in this case, I mean, I could do the calculation, but I'm not going to do it because we don't need it. Since this is 0.05, this is 0.05, we agree this is going to be in the middle, no? That's why it's symmetric. But if we had to calculate the centroid, if, for example, we had another force over here, so let's say we have here dy, so let's say this would be the neutral axis. So in this point, let's say this would be dy here. If we had a Vx, we know the Vx, if we have the Vx, then we know this is going to bend also on this line over here, no? Yeah? So then we will need to find the location of the x, no? The centropesis. We don't have to do that. Let's save some of that. So in other words, we don't need to find the Iyy. Okay? In this point, we need to find the Ixx, no? Okay? So the only thing we need to do is the Ixx. So this, in this case, I'm going to do the approximation. So I put over here using thin structures approximation. And the only reason I'm going to use that one is because it simplifies a bit the numbers, actually a lot. But if you do the other one, it's fine. So the simplify will be equal to what? So we do 112. What will be the one for this side over here? And this side over here will be 112. What should be the base? The thickness, no? T23, correct? Base times height. Remember, this is like if you do this one. we start by 2 and 3. So what will be this? Then will be S23 cube. This is an S23, okay? I'm going to do the one on the other side. I was going to multiply by 2, but now I'm doing this side over here will be 1, 2, 3, T for 1, S for 1, cube. Plus, I'm going to write the term over here, but you will see why this one is Johnny neglected. What will be now for member 1, 2 or 3, 4? What will you have? What should be for 1, 2? So 112 over what? The base will be this time S12, and the height of this element will be T12 to the cube. Okay, now this is about this axis. So what do we use in order to move it from here to here? The parallel axis theorem. So for example, we use the parallel axis theorem is I prime equal to I plus A d squared, no? Okay, we have done that before. So what will be the area of the top one? Will be S12 times T12 times what should be that distance right here? S12 divided by 2 square. Now, this is the small structural approximation. What is T12 equal to? It's equal to 0.005. All right. So if you take this value to the cube, what's going to happen to that term? It's going to become very small. So actually, you could say this one is going to be close to 0, no? But if you don't want, you don't have to, okay? Does that make sense? All right. So we did this one over here, T12. Now, we can do exactly the same thing for the one at the bottom, no? So it will be the same expression, 112, S34, T34 cube, plus S34 times T34 times S34 divided by 2 squared. And again, this one will be very close to 0.
The S or the T cube that's supposed to be close to 0?
The whole term. The one is very small is the T. So this will be 0.05 to the cube. So it's going to make this whole term very small, no? Okay. So if you start to do the values, okay, I'm editing this stuff in MATLAB. This should give you, let me execute the file. All right, so that gives equal to 62.5 inch to the 4. Okay, if I was doing it the other way without making the small structure assumption, I think I was getting a little bit high, okay? But you will see instead of one value of being 2, it was 1.978 instead of using 2, okay? So let's use the 2 over here. And let's use that value. All right, so now what we're going to do is follow the normal procedure. Okay, this is a closed section. What do we do is we want to calculate the shear flows. What is the general procedure? We have here the closed section. And we do that one. All right. We make a cut.
Yeah, you move the paper.
Yes, that's what happened when I zoom. So let me zoom out a little bit and then I zoom back in if you want. That will be the last line that I write. So we do this. We make the cut. Okay. First step, we calculate all the shear flows. And since we made the cut, that means that we're going to have here inside some internal shear flow, no? That's what we have been doing all the time. So this is what we do generally in the steps. So let's do step one, make the cut. So step one, make cuts and calculate shear flows. That's basically what we do. So in this case, let's make the cut. This time we need to be a bit more picky because the equation is more, it's a bit harder. A lot more calculations doing this, so I'm going to be honest with you, I'm not too crazy about it. All right, so we make the cut over here. And let's call here this point. Oh, no zero, but oh, okay. Okay, so you want cut in segment 3 at the neutral axis. Maybe I should call it different at that point. Okay, so why do we start there? Because then what do we know at that point? Maybe I should call it differently. Let's call it, what letter can we do with this? P? No. Yeah. D. Let's call it P. Because then at that point, what we have? Q of P will be 0, no? At the neutral axis. We make the cut over there. Okay, so now remember the equation, the general equation we're going to be using is Q equal to minus Vy over Ixx yes, ds. So it's different than the one we were using before. Okay. So let's call over here. We're gonna have a lot of this stuff. So segment P2.
So the reason why we have a much smaller Q equation is because it's symmetrical, right?
The reason we, yes, because Ixy, let's go over here. The reason why we have this time much more is because we simplify a lot. Vx is 0. And because of the symmetry, Ixy is 0.
Okay.
And all these terms, we're not considering any of these two terms.
And then what about the thickness of the struts?
We have the thickness here, we have T.
Okay. Oh, it's because it's 0. We don't have to consider.
No, this one will be 0 this time. We don't use the long joints, okay? This time it's only skin. So this time we only have these terms over here. And I'm calling them S because not to call X or Y because as we go around, one will be X, one will be Y, and so on. Okay, we need to go around the structure. So that's basically this equation here simplified for the symmetric and the X equals 0. So if you want, let's put it here. I xy equals 0, px equals 0. We assume that there is no string, there's no anything. So that's all that stuff is going to give this simplified equation. Okay. All right. So here we are. So we start from here. So let's say this will be our first S. So we are gonna have Q P to 2 will be equal to what? P, we just made the cut. Minus Vy over Ixx into of what? T to 3 times S ds. And I'm not going to start giving different names for the ds because this is going to become way too complicated. So if I do this, what is QP? Is when we made the cut is 0. So this is going to give minus Vy over Ixx e to 3 times what? If you do the integral, s squared over 2. Okay, if we do the simplification, this is going to give QP2. And looking at the MATLAB will be equal to minus over 25 s squared. Okay, so basically what do we know over here? We know that a point Q, how do we call this one? QP is equal to 0. Now QP2, so basically at point at x equal what? S23 divided by 2, no? At the top over here, which if you want, we can call this one Q2. So basically, you just substitute S by what? By S23, I think this was 10, no? So that would be 5. 10 divided by 2, 5. You find that value today. I need to look over here. That's why I did all this stuff. The negative be equal to negative 2. Okay, so if I needed to do a plot, oops, okay. P 2.2, the way this is going to look like. So basically we'll be here to negative 2, and this will be here 0. And then I will do a different plot, okay? Okay, so once again, we start over here. We need to go all around. Do you kind of remember this? Do you kind of remember this from structures 1? Probably you did that with the C section where you go around and no? Anyway, so now we're going to do what? Segments. One. That's probably the easiest one. So how you over here? You have Q. Wait, is this one? So now I have Q to 1 should equal to what? Q2. The one in the corner minus Vy over Ixx integral, this time of T12 or T21. Okay, maybe let's go back to the initial equation. Maybe let's look at something here. Maybe I was trying to simplify. I'm not simplifying anything for the understanding. Here we go. So in this equation, so all this term will be zero, no? So we'll be left with this term over here, correct? Yes. So really the term, the S, the stuff I'm putting here is Y. Let's put Y ds instead of S ds here. Let's put Y ds would be more accurate. Sorry for that, but I think it's going to make easier the understanding. So once you go over here, put T Y ds. This would be T Y ds T Y ds. So in this case, you see that the Y, I call it S, just because I make it to go around. In this case, I go section 2-1. So if I do a little plot, in this case, this will be 2 and 1. Let's say this will be the neutral axis. So in this case, Y is equal to what? What will be Y equal to? S23 divided by 2. Perfect. That's why I just changed the notation, because I didn't want to have too many stuff. So in this case, we're going to have Y equal S23 divided by 3, S23 divided by 2. So this gives us what? Negative 2 minus Vy over Ixx times T12 times S23 divided by 2, that's Y, times S. No, when you do the integral of the constant. All this term will be constant, no? Yeah. So you do this will become S. So let's see, if I look at the MATLAB, then this will give me Q21 will be equal to over 5S minus 2. So for example, the expression of the function here was what? Square. So that means that is parabolic, no? In this case, this is in function of S. So what does that mean? This is going to be linear, no? Okay. So if I needed to do a plot, some type of plot, this could come from, let's say, -2. I didn't give that value now. I give it to you now. I'm going to write it down to -10. So that basically means what? That at so Q1, so Q21 at the distance S12, if U1 will be equal to Q1. So you substitute here the S equal to 10, to 20. And this is going to give you Q1 equal to -10. Yes, sorry. 20, 40. Basically, if you do this, this is 20, this becomes -8, -10, -2, -10. Okay, yes.
So you got a graphic drawing, is it linear or not?
This is linear, yes. This is a linear line, correct. This should be a straight line over here. That is a straight line, this is a parabolic line, okay? You're really negative. What does the negative sign mean? Is that it's not going, it's instead of going up, it means that it's going down, no? Yes? Okay, same thing over here. This means that instead of going from 2 to 1, it's really going from 1 to 2, no? So then I will change the figure, but for now, let's just do it that way. Okay. We did P2 to 1. Now we're going to do 1 to 4 over here. Let's call it P prime. That way will be symmetric. So to P prime over here. So next cut will be segment. This is probably these are the difficult ones, the one on the sides. Segment 1, P prime. Okay, so if I do a small figure of that one, we'll have here 1, P prime. Okay, here maybe I should have put that this was still the S over here, but it was constant. This is our S, but the Y was constant. Now we do the Y again. This will be our S, but this will be our Y. Okay. Remember, here we have the neutral axis. So once again, here we're going to have Q1 P prime should be equal to Q1 minus Vy over Ixx. And here I'm still going to put Y, but then we're going to find what Y is. So T1, T41 or 14, doesn't matter. T14 times Y ds. Okay, in this case, what will be Y? Y starts from here. What should it be? S23. Okay, so S23 over 2, perfect. And then we're going to be moving S, no? So that when S23 equal to this distance over here, you're going to have Y equal to 0, no? Yes. Yeah, so let's rewrite that equation. We're going to have Q12. This is this Y over here. Okay, if I call it bar over here. Minus Vy over Ixx. Integral of T14 times S23 divided by 2 minus S. This is our Y. Y or Y bar, whatever you want to call it. So if we integrate this, what do we get? We're going to get Q1 P prime will be equal to Q12 minus Vy over Ixx. Let me put the T14 outside as well to simplify a little bit. Remember, this term will be constant, correct? Yeah, so will be S23 divided by 2. Well, S, use a different color if you can. What? The integral for this one will be S squared over 2. But remember, this is, I'm doing symbolic because that's the way I have it. So hopefully I have the number for this one here, the calculations. This is Q1P. Okay. So I guess this is this equation here. So if I look at the so this is going to give Q1P prime equal to 0.04 S squared minus 0.4 S minus 10. Okay, and the value of Q1P prime at S23 divided by 2. So at this point here, let's say will be Q P prime yields to negative 11. So if I needed to do a figure from 1 to P prime, that would be equal to what? This is the value at point 1 that we had before. Negative 10, no? Okay. Now we know at the middle is going to go to, let's say here, to negative 11. And what would be the shape of the equation? Should be parabolic. So something like that. All right. I mean, you can do the rest by symmetry, but since we're doing this together. Yes.
Sorry, the Y bar, is that S23 over 5?
No, S23 minus S.
Oh, over S minus S.
No. S, sorry, no, you're right. S23, you're right. It's not perfect. Divided by 2 minus S. No, good. No, good call. It's my fault here. Okay, S23 divided by 2. Yes.
So the reason on this graph, you put the negative on the right.
Yeah, just because the reason because I have space on the right instead of the left. Okay. Really, the negative sign doesn't mean anything. It just means that it goes in on the opposite direction, and that's what we do at the end. Okay, so now that we are here at point P prime, we can go now to P prime to 4, no? Okay, and we keep going. So, all right, so segment. P prime to 4. So we go whatever from here, P prime to 4. Again, now this will be here. Oops, wrong color. This will be now S or Y, okay? So we're gonna have again Q P prime to 4 should be equal to what? Q P prime minus Vy Ixx integral of T14. And this time, what is Y? Let me put here Y ds. This time, I know before I call it Y bar, you can remove the bar if you want. It's just because I did it by mistake. What is Y equal to this? This Y equal to now? This is a reference, no? Negative S. So this is going to give Q I mean, I could put values, but QP prime minus VY over IXX. T14, I integrate S2 over 2. So when I look at the MATLAB, it's going to give me Q prime P prime 4 equal to 0.04 S squared minus 10. Okay, and let's see now if what we did is correct, what should we get at Q4? So let's say Q P prime 4 at S14 divided by 2. Oops, why I put here S23? But be careful here. This should be what? The height. So 1. Oh, it's the same thing. So S23 divided by 2 is fine. That should be equal to what? At Q4, what should be the value if it's symmetric? Equal to -10, no? This is the out, so should have here -10. So if you want, you can check. Wait, is that possible? That's what the math are giving, but looking at the equation. Okay, that's what the math is giving. So, okay. So basically here, that means that what we're gonna have over here is four. We have the -10. We have over here the 11. The -11. Oh, it's negative. Okay. Hold on 1 second. I want to look at something here that is correct. We just did Q4. Let me activate this one, see if I'm looking at the right one. On the MATLAB, here we go. Let me rerun it. Okay, so Q4 minus 10, 0.004 S squared minus 10. Okay. So next segment will be what? For 3, this should be the easy one. Because in that segment, what happened? The Y is constant. Segment for 3. So let's do here. For 3. Neutral axis. This will be the Y. So we're gonna have Q43 will be equal to Q4 minus VY over IXX integral of T 3, 4. I'm going to put here Y. I know before it was called Y bar, but I mean, let's call it Y bar again if you want. That way it will be the same. This time, what will be Y bar? Minus what? Is constant minus S23 divided by 2, no? Which is the height over here. If we need to put values, I put values. It will be -5. Okay, that makes more sense. So this is going to give Q4 minus Vy over Ixx E34 is minus S23 divided by 2 times S. So if I look at the MATLAB code, Q43 is going to give me that is equal to this one should be linear, 0.4 S minus 10. Okay, so what will be the value at 3? So let's say Q for 3 at the distance S12, which will mean all the way to the end, will be equal at Q3. And that should be equal to what, if what we did initially is correct? -2. So basically on this one, what do we have? On this one, we start at -10, we go to -2. All right, finally, what is the last segment we need to do? 3P, no? What is it gonna look like? It should look like this one, like the one we did between P and 2, no? We could have done everything by symmetry, but let's follow the procedure. So last segment will be segment 3P. Let's look at the MATLAB code. Here we go. So Q3P will be equal to Q3 minus Vy over Ixx integral of T. What should be this one? 2, 3 Y ds. So here be careful because this one might not be that easy to do this one here, like. So here we are P, we are 3. And this is S. What would be Y in this case? What did we have before? When we went from here to here, to 1 to point A, to point 1 to P prime, what do we have? Okay, so it would be, but leave some space, would be S23 divided by 2 minus S, but this time is going on the opposite direction. So it should be minus S23 minus S5, no? Because we are under the line over here of the natural axis. Okay, starting from the top, we start from the bottom, no? Okay, so here we go. So we do the calculations. I would give you. So we'll give you Q3, which is actually minus 10. So Q3 minus Vy. So plus Vy, since this is negative. Maybe I should not replace, but it doesn't matter. Ixx. E23. And this should give you now what? S23 divided by 2 S minus S squared divided by 2, which was the same that we had initially. Or this will give Q3P. The equation for that will be minus 0.08 square plus 0.8 S minus 2. Okay, so finally, if you want Q3P at distance S23 divided by 2 is equal to the Q P, that should be equal to what? What should QP equal to? 0, because it's the location where we made the cut. So this should be equal to 0. We didn't do a mistake, that gives you 0. And that's what we're getting here, okay? You want to show you here. I mean, it's not that useful, but so many calculations that I use it anyway, okay? Oh, so sorry. Sure, but the other one, oh, the executable file should be at the bottom or not. Okay. I mean, I just want to show you that the application. Okay, let's see how can I do this. Let me move it back here. And I'll move it back there. Once it's this one that I want. Okay. So just want to show you that here the MATLAB does not give me 0 exactly, it gives me very close to 0, no? Yeah. I mean that's from where I got all the expressions that we have been doing so far. Basically, I know this is long. What we have done over here is the first step. So let me do the plot. So what was the assumption we were doing initially is that if this is 1, 2, 3, and 4, if it's positive, it means that it goes in that direction. If it's negative, it means that it goes in the opposite direction, no? Okay, so let me do the first sketch over here. You want? So let's say we'll have over here, our first sketch will be, I'll make here one cut. Let's do this, this. Yeah, so 1, 2, 3, and 4. So how was our figure? Our figure was going really from, let's say, here 2, so, or minus 2 to 0. Minus 2 to 0, no? But we had negative value. So the negative value actually means what? Is that instead of going from point P To point 2, it was going in what direction? Was going from point 2 to point P, no? Okay. Here, the negative sign was meaning what? Instead of going from 3 to point P, it was going from P to point 3. So this is really, if you really want to look at this really will be the Q to P. P3 will be that way. Then what did we have on that side? We had this was going from 2, maybe I should have give more space, to 10, no, on a linear. But we had negative values. So what does that really mean? Is that this is going from, instead of from 2 to 1, is going from 1 to 2, no? Yes, here we also have negative values. So in this case, what was the value? Was going from 10 over here. Let's do maybe both of them at the same time, 10. And I know it's not going to be to scale, but was going to 11. So let's say 11 and 11. And it's not even in the middle, but that should be right in the middle. And on this one again, we had a negative value for both of them. This was our P prime. So basically that means that this goes this way and this goes this way. Here, what do we have over here? This was going from 2, negative 10 again, on the opposite direction. So that means that instead of going from 4 to 3, this was going from 3 to 4. Yes.
For sections 1, P prime and P prime 4.
Okay, so segment, which one you said?
The right side, the uncut side. Could we have done that as one continuous?
I mean, you could have done this one by symmetry. You could have done just from here to point P and then symmetry, just like this one here. And this side as well. The reason I wanted to do everything is because we don't use a textbook to give you everything, but you could have done just this part, complete this part by symmetry, do this part, complete this one by symmetry, do this part and complete this part by symmetry. So really, if we wanted to be fast, we could have cut the work by 2. Does that answer your question? Or?
Not quite. So we broke the 1 to P prime.
Oh, I think I understand your question. I think your question is that you wanted to break this in one piece.
Yeah.
Okay, so the question is, the answer is no, because what is y by definition? Remember the y we always calculate is the distance. I don't want to do it in that figure, but it's the distance from where? From the neutral axis. So you see that the neutral axis will be somewhere over here. So you won't be able to find one expression that gives you for both sides. Okay, I understood your question. So now, bad news, we only did this part over here, no? What do we need to do now? This one over here. All right, so the more tedious part, okay? Now it's going to go a little bit faster. So step 2. Let's evaluate Q sub naught. Okay, so in order to do that, what did we do before? Oh, first, this problem is it statically determinated or indeterminated? This one would be statically determinated, no? Okay, if we add one other section that is not needed, it would be indeterminated. So in this case, when we do this, instead of you doing the same angle of twist, and then the moment, we only need to use one equation. Let's do summation of external moments be equal to the summation of internal moment. Okay? No matter what, I'm going to finish this problem. So, to simplify the equation, to simplify the process. Okay, to simplify the process, to tell the truth, I think, yeah, I did something wrong on the first figure here. Everyone pay attention. This is not dy, vy is over here. Because I need to get everything from the MATLAB. Vy is applied at 0.2. And they give us in the problem that is equal to 100, but the way I did it, we don't need it. Sorry for that. So if the force is applied over there, let me redo the figure over here. One, two, three, four. Okay, we have now the Q sub naught over here. All right, and we have the Vy over here. So in order to simplify the calculations, what I did is what? I say, okay, let's take moments about 3. Okay, and let's say counterclockwise. Counterclockwise positive, it doesn't matter as long as you are consistent, but I always use counterclockwise positive, so let's do it that way. Okay, so in this case, this is going to be simplify a lot. What would be the moment created by the external force? V1 is the force, what is the arm? 0, so down will be 0, no? Okay, now, the moment created, so the moment created by 2 and 3 will be 0 because the arm is 0. And the force created by the segment 3, 4 by the shear force will also create a 0 moment. No. So we only need to consider then this force over here and this one over here. Okay, so I'm gonna do this stuff. Okay, so let me put it over here maybe. We have here 2, 1. What was 2, 1? If we look at the figure we did, it's 2. We go from 2 to 10. That distance over here is 20. So let's say the integral of all these surfaces Q12. So you can do this by geometry. You just do the area of the rectangle plus half the area of this rectangle on top. You know what I'm talking about? Find the area, no? Will be okay. Or you could what do? You could do just the integral of this section, which is what I did because I wanted to do it with MATLAB. So now I lost my stuff. So let's see what was that expression. So Q12 should be equal to the integral of Q12 minus Vy over Ixx T12 times S23 divided by 2 S, no, yeah, ds, and this we integrate this between 0 and S12, which is 20. Okay, I give you the value now. So you can do this again by geometry, by just looking at it, but this gives you that Q12 is equal to I minimize everything and now it's lost. So it's equal to negative 120 really, but let's say 120, okay? Let's just look at the value, just per 120, absolute value, okay, minus 120. Yeah, the thing is that then what do we do when we take the moment? So, all right. Then the other moment that we are concerned is what? Q will be for 1,4. So that one, what I do, 1,4, I do is going to be twice the one that I do for 1 P prime. So that should give you here two times the integral 0 to S 1,4 divided by 2, and the expression we had over here is Q1 here is Q2, not Q1 to Q2. Q1 minus Vy over Ixx T14 times S23 divided by 2, which is a constant. I should have put here brackets, sorry for that. S23 divided by 2 times S minus S squared over 2 ds. And if you do this, this gives you a value of minus 320 divided by 3. Can somebody do that calculation? I think it's 106.67. But if you can do it, so negative 106.667, okay? Okay, and this will be for the value here, 1 to T, which integral is, again, this one right here from 10 to 11. So this is the value we call here Q14. Okay, so if you remember, we said this one was going in what direction? Figure now that was going to the in that direction, no? Because of the negative sign, it was going on the opposite from instead of from 2 to 1, was going from 1 to 2. I'm looking at this figure, okay? Again. And then these ones were here going up. Okay, so if you want, this will be the force Q. If we look at the forces, it will be the force Q14 instead of shear, and this will be Q12. Okay, so what will be the moment created by the external force? Yes. So I'm moving up now. So about point 3, the one of the internals, what will be the moment created by Q12? It will be Q12, but let's put the absolute value, so the positive here. Okay, let's say Q12. Take the absolute values. I know I put here the negative values, but it should be the positive values. Q14 equal to 320/3, yeah. Because you see, take the magnitude, because this is going to create a counterclockwise moment, no? Yes.
Is that area in the graduate, is that Q14 or is that Q14?
Which one?
To the left, the other.
Oh, this one here.
Yeah,
This is Q1P if you want, yeah. Because you multiply by 2. So this one, at the end of the day, I only did half of this, and I multiply by 2. No, this, actually, I'm not clear about these problems. Okay, but you see now what I need to do. This is Q12, what would be the arm? No, because we're talking about 0.3. So it should be all S23, no? Okay. And I take the magnitude because I already put the sign over here. Then what would be Q14? Will also be creating a counterclockwise moment. Q14 times what? S43 or S12 doesn't matter, whatever you want. S12. But let's not. What do we have over here? The Q sub naught. So what is the moment created by the Q sub naught is A sub naught, no? Remember on the cross section, what will be A? S12 times S23. Okay, so just give me please 3 minutes. I promise you next time I let you go 10 or 10 minutes in advance, okay? I'm not going back to these problems. Okay, so all this stuff over here is going to give. So by doing summation of internal equal to external, this is going to give us the equation 400 Q sub naught plus 10,000 divided by 3. So this is going to give you that Q naught will be equal to minus 25 divided by 3, which is equal to minus 8.333. One last figure. Okay, so finally, what do we need to do? Remember that distribution over here? We need to add the Q sub naught. The Q sub naught, since it's negative, is actually going on the opposite direction, no? Okay, so step 3. Final distribution you copy it. I'll put on the figure here. Now I'm going to put on the, yeah, and I glue it. That's fine. Don't feel like doing this at all. So when you add the Q sub naught, this is what we get at the end. So basically, you need to subtract the whatever, the 8.33 to, or add it in some sites. I know you can do that. Take a picture and then just put it in your notes. That's pretty good, huh? Otherwise, copy the figure. So as you can imagine, this, I will just give you an assignment problem and we forget about it, okay? So now imagine that you had to do in one of the problems we did, like the ones of the booms, combined with this one. Not fun, no? That's why the aerospace stress engineers are generally the best, okay? In structures. They need to do all that stuff. Like I tell you, I don't think it's that useful, but. At least you need to see it once. Sorry for this lecture. But not everything is fun. Have a nice weekend. So let's see. Only one? Well, first exam, I'm estimating that once you return the next class. Yeah, so next week, probably the following. Thank you. No problem. Yes, is there any put, can take some from like the 14
weeks or months, so.
14? On my birthday?
Next Tuesday.
This coming Tuesday. On Valentine's Day, perfect. That way, you know, I'm going to right after Valentine's Day. That way people don't go on any, not don't go on. Yes, I mean, is it a Tuesday the 14th? Yeah. Maybe the 14th, yeah. But we can discuss it. I'm not picky, okay? It's gonna be that way. And next class, probably we discuss either that Tuesday or that Thursday. Is that enough for information?
Yes.
Okay. Yeah.
If you could post like the partial answers for the homework, it's like just like what the cues should be, so I can check to see.
Oh, no, that's the stuff. That's the. I mean, the answer go. Did you have Radosta?
No.
It's on Radosta plus. Let's get it out. But I mean, it's.
Oh, I guess if it's since it's
For the first one, I don't mind telling you.
yeah.
Well, I mean, for the second one, I get slightly different answers. So I want to get to see guys what you get.
Oh, fair enough.
The first one is straightforward.
Well, yeah, I printed an aspirin.
Okay, so
The second one,
you did the whole problem in Aston?
the first one, yeah, for the first.
Oh, you did it in Aston? And you got the same values?
This,
Similar, yeah. Do you mind sending me that Aston so I can look at it?
I'll.
If you don't mind. If you share that with me, I share my values. Is that okay?
Yes.
Thank you. Yeah, no worries.